screen here, so like some of slides there will be as much a surprise to me as it is to you. So yeah, don't be afraid that I'm looking there quite much. All right, so I don't have clicker. Okay. All right. Next thing. First of all, okay, I'm a data scientist. I work at Yandex.Taxi, but I'm telling you about this urban stuff because like earlier in life, when I was studying in university, I was also very into urban studies as well. I was a huge fan of Strelka. Of course, it was very deep, but still, I mean, I knew a bit about it. So okay, first of all is the outline. I will familiarize you with machine learning. I mean, the general concept of this. Then we will talk about like a normal day in the life of a city dweller. I mean, just the citizen of some city. Then we will a bit more precise. We will talk a bit more precise on some services that transform cities right now, like it's happening today. Then we will talk about how machine learning shapes this transformation, like literally today, and it's already happening. And then I will talk about the future. I mean, that's a speculative topic because, I don't know, no one knows the future, right? And the last thing, I think that will be the most important part, the takeaways. Okay, so, no, it's not on me. No, I don't have it. Okay, so, all right, machine learning. What is machine learning? Next one? Yeah. All right, what do you need to teach machine to do something? Okay, I get it. Good. So first of all, you have data. I mean, data is everywhere, right? Every time you make a phone call, every time, I don't know, you order a taxi or do anything, someone is recording something from you. And cities have a lot of it. Then, what do you want to do? You want to feed this data to algorithm? I don't know, it can be anything, right? I mean, just some robot, some computer. And then you want to get some labels. Or I don't know, maybe not labels, maybe some numbers. That's the general idea of machine learning. You have data, you want to get something out of data, and you just feed it to the machine. I mean, in the simplest case, for example, you have pictures of cats and dogs, and you want to teach a machine to classify a picture like being a cat or a dog. And that's the simplest case of machine learning. So, of course, cats and dogs is not the end of it. So, cities can do a lot with this machine learning idea. This one. Okay, so what do we need to teach a machine to do something? Like, not really teach a machine to do something, it's the simplest thing we can do. But what can we do in order to deploy some machine learning solution in the city? Okay, first of all, we need data. I mean, without data, you can't teach machine to do something, anything, right? Then you need to have some interested parties from industry. I mean, no one is going to do anything if it's not for some benefit. I mean, not always money, but still. I mean, they have a rubble sign there, so maybe it's important. I mean, that's really important. So you should have at least like one IT company, or not IT company, any company that is willing to invest in some machine learning solutions for the city, right? Then you should have some authorities, right? Because, for example, I can develop some face recognition system, but if I just try to deploy it, everyone in the government is going to be like, what? What are you doing? Like, why you're, I don't know, making photos of people on the streets? It's forbidden. So all these machine learning industrial solutions should comply with some policy, and policy comes from authorities. That's why we need them. And the last thing is benefit. I mean, you see these interested parties. This interest originally comes from some expectation of benefit. But what we really need in order for this machine learning solution to persist in the city, for it to be deployed and I don't know, dwelling in the city, we need some real benefit. So after you deploy it, this solution should be beneficial. And I mean, it's the only way it will be viable. It's the only way it will persist in the city. Okay, so when we have all four, we can start building something. That's kind of the general pipeline of machine learning, not in the city, but in general, actually. Okay, now let's talk about some normal day of some normal citizen. First of all, what does he do? I mean, your ideas. What does a person do in the morning? I mean, after you have breakfast, what do you normally do? What?
Transit to work.
Yeah, transit to your workplace. Okay, so you need to get to work as fast as possible, and I don't know, you want to minimize some hassle, you know? Like, you don't want to do it in rush hour, you don't want to be in traffic jam, you want to, I don't know, you want it to be easy. And, okay, that's totally understandable. Then, for example, you're working, and you're just sitting in your workplace, and you're thinking, alright, maybe it's time for lunch. For example, I'm working in Paveletskaya, on Paveletskaya, and sometimes I just in a situation where I want to eat some pizza, for example, Pizza Maestrello, right here, nearby, but it's actually quite far away from Paveletskaya. I can't go there because, I don't know, I cannot be absent for 4 hours in the middle of the day. So, maybe I should order it, right? Because I am willing to pay someone to bring this food for me. Yeah, that's a good use case. I mean, of your time, because you save it. Okay, then, for example, it was a tough day. I mean, really hard day. And okay, let's think that you have a driver license, okay? Because I don't have it, but maybe some of you have. So you might drive home, but you're thinking, well, I'm too tired. I wanna make it a taxi. So you just want to order a taxi. Then you come home. I don't know. Maybe you have some co-livers with you, and you want to share a meal, but you also want to cook it because you love cooking. Or maybe, I don't know, you're not really into wasting a lot of money on this second delivery in a day. You want to save a bit. You want to save a bit and also cook. So you order some pre-cooked meals that you can actually finish. I don't know, like, I think much of you are familiar with this concept, right? Yeah, and finish with something fulfilling. I don't know, watch a movie or a series. Yeah, maybe. Why not? So, everything that I just said comes down to some service. For example, these ones. Yeah. So, anytime you want to do something in a modern city, you use some app. I don't know, not any time, but most of the time. So, yeah, you just use them, and that's good. Life is good. Okay, now let's talk about how these services actually transforming the city. Because, you know, if everyone is doing this, I don't know, for example, if everyone is ordering some pizza, I mean, at least this pizza place is going to be famous, and I don't know, maybe it will become a bit more expensive. Or maybe the pizza places around it is going to be broke in a year or something, right? So it's changing the city landscape. Okay, so let's first talk about navigation system, because I think that right now it's the most beneficial to the city service of all. Like, it's the most important one. Okay, so how does normal navigation system influence the city? First of all, it decreases congestion. Why? I mean, that's obvious. If you want to find like fastest route from A to B, I don't know, maybe 20 years ago, you had to just take a map and sort it out yourself. But now you have to click, I don't know, maybe 3 buttons, and it's already done for you, and it's optimal. I mean, much more optimal than you could have ever done yourself with a map. Because you don't know all the situation on the road, right? But the service knows it. So your route is the fastest one you can possibly imagine. And if everyone is driving faster, then there is less congestion in the city, right? So this is the main benefit of navigation systems. Then, yeah, you know, the next thing is increased traffic system utilization. The point is, for example, some authorities are building roads, They don't have this data-driven urban design, you know. They just do it the old-fashioned way. They just see like, all right, these guys, they need one more road, so we will build it here. Why here? I don't know, because I mean, that appears to be okay. So yeah, they do it. But later on, they discover that no one is actually using these roads. And why no one is using them? Because everyone is really attached, like without this navigation system, everyone is really attached to huge roads, right? For example, if you want to get from Paveletska to Park Kultury, you're finding yourself, like, you have a choice. You can either, for example, look in a map, find some route, I don't know, maybe a bit above the Sadova garden ring, or the garden ring, sorry, yeah, above the garden ring, but what most people do, they just stick with the garden ring. And we have a traffic jam there, like a huge traffic jam. We actually have with navigation system, but still, that's for the sake of example. You have a traffic jam there. But if actually you Googled your route or used this navigation system, you could just use some another routes that no one is actually using. So now these roads become not really, I don't know, obsolete. They become like useful because people use them, and that's the second benefit of navigation system. The third one is increased public transportation usage. Why? Because you know. Sometimes you just open this navigation service and you see that road home will take maybe an hour in a car, but if you use metro, it will take 30 minutes. And yeah, you stick with the metro. So that's kind of a bit leads to increased public transportation usage. And then decreased exhaust fumes per car. Again, as I said, if everyone is driving faster, most of the people need to do just 2 trips per day, right? To work and back. And if these routes come faster, then you just drive less. And if you drive less, there is less exhaust fumes. And that's good for the city. Like really good. Yeah, the next one, my favorite, because I work there. First of all, what these taxi services do? They create very, very, very much new workplaces. Just imagine. Maybe 5 or 10 years ago, you were having a conversation with a person from some kind of I don't know, from abroad, like mainly I don't know, maybe in a shawarma restaurant or something. But now you find yourself talking to foreigners, mainly in taxi. And a lot of people from abroad came to Moscow to work in taxi. And you know, like they bring their workforce here. It creates more GDP for the city. It makes city more lively. It makes your life more comfortable. And in general, that's amazing for the city, right? Then, again, decreased congestion. I mean, that's not really the point for Moscow, because you know, in Moscow everyone is riding alone. No one is using these pool rides. Like, have you ever heard of pool rides? Has anyone? I mean, has anyone done it in Moscow? Anyone? Raise your hand. No? Okay. Well, but in San Francisco, in New York, that's the common practice. I mean, everyone is using these pool rides because that's very, very, very cheap compared to the normal ride. Yeah, and if 4 people are riding in the same car, then there is 3 trips less per day. And it means there's less driving, less cars, less exhaust fumes. That's great. Oh, and also, yeah, the congestion decreases because there are less cars on the road. Then, decreased parking lot usage. That is kind of obvious as well, because if the driver is driving constantly, like through all day, then he's not staying on any parking lot. And then parking lots are free. And if they're free, we can maybe get rid of them, right? And free some space for, I don't know, for development, for parks, for anything, basically. Yeah, then I already said about exhaust fumes. And, you know, in some way, these taxi services, they're decreasing your driving time. I mean, that's not always true, but in some cases it is. For example, when you're sitting in a taxi, you don't really drive, right? You can do anything. You can Google something, you can read, you can watch a TV series, or anything basically. So yeah, it just saves time for you, and it saves time for a lot of people. And you know, like this 20 minutes a day for you, that might be like not much, but if we count this 20 minutes for, I don't know, maybe 20% of people in the city per day, that's quite a lot of time. And that's the time when people can get creative, when people can create something, not just drive. So that's also an important point. Okay, car sharing services. You know, when I was doing this presentation, I was thinking that, well, car sharing is gonna blow it. I mean, that's gonna be amazing. How much good it can bring to the city. But actually, when I thought about it, I found that it's not as much as I expected. So I came up with just 2 points. I mean, big points. First of all, is decreased parking lot usage. That happens because, for example, when you need to commute to work, you just hit this car sharing car, you drive, then you park it, then 10 minutes later, someone else is taking this car. So, but without this car sharing app, there would be 2 cars staying in the parking lot for all day. And now it's not true, right? So there's a huge point, there's a huge plus of car sharing services. Next, improved city car composition. Who understands? What does it mean? All right. I mean, maybe you're shy, okay? Yeah. What does it mean? It means that if you have car sharing, all these cars that are in this service, they are standardized, right? So I don't know, they're all new, they're all comply with some kind of European regulations on exhaust fumes and all the good we can imagine. But without them, there would be more cars actually, and you cannot guarantee that a person who is driving car sharing now would buy the same car, right? So maybe this person will buy a much cheaper car, which won't comply to the rules of, to the regulations of exhaust fumes, right? So that's also a big deal. I mean, when car sharing is actually conquering the city, when car sharing, I don't know, maybe takes 20% share of market, like of car market, it really improves the overall age of cars. And the overall age of cars is actually leading you to the more clean city, the cleaner city. Yeah, the next one, the transport information systems. I mean, some of you might have this Yandex Transport app, and actually, I think, you know, it brings very, very, very much good into the city and very much good into your lives, but it actually has a starting point, and the starting point is increased public transport usage. Because, you know, this app is making the transport usage predictable. Before Yandex Transport app, you could just rely on some kind of timetable, and you know, in some countries, timetables are infamous for being not really calculated, you know, not precise. But now you can just forget about this timetable and just see it in the app, and the app just directly analyzes the traffic, and it sees all the buses in real time, so it can predict like the real time of bus arrival, for example. So it makes service predictable, and you start to trust it more, you start using it more. So sometimes you might actually drop a taxi or a car ride for public transport because of this app. Yeah, and this point brings a lot of other good points, right? Because more public transport usage means less exhaust fumes, means less cars, means decreased parking lot usage, and all the good you can imagine. Next one, food delivery services. Okay, that's an interesting one because it's not really connected to transport. First of all, people start ordering food more and eating in a restaurant less, right? So maybe some restaurants would consider decreasing their area, like their seat area, and increasing their kitchen area, right? Because they need to cook more now, and I don't know, they don't have really much customers appearing offline. They have these online customers which they need to just cook food for, and that's it. So that's an interesting thing, because maybe in 10 years you will find yourself walking in a restaurant and there will be just only 2 chairs, and yeah, and that will be it. Yeah, then increased eating out. I don't know why is it really good, but maybe it just you know, enables people to try something new. Because when you're at home and you're cooking, I don't know, like every morning I eat some kind of porridge and that's it. I never try something new. But if I start to order something, if I have options, if I have, I don't know, maybe 10 restaurants in a row, I can try them all in 10 days. And maybe it's good, maybe it's not, but I think tasting something new is always good. So, again, new workplaces. As in the taxi service, you know, we have this Yandex Eats, and there are a lot of delivery guys, and yeah, like a lot of people came to Moscow to work in delivery as well. And it also enables students to work, because there are lots of students working as couriers in Yandex Eats. So it actually, yeah, it also grows like the GDP in the city, and that's a good thing. The last one is streaming services. That, you know, that is very sad for me, like the most sad one, because I really like to go to cinema, and I really like to watch movies offline, but I find myself in a situation when maybe in 10 years there will be no cinemas, or maybe there will be like, I don't know, maybe like a couple of huge cinemas for the whole city, and no one is actually attending them, just some weird guys like me. Yeah, so when these streaming services grow and they become much better, they have better recommendations, they have better everything, they have a lot of content, they start to make their own content like Netflix, which is not transferred to cinemas, which is only available on these platforms. That actually means that people will start to consume this content at home. They don't really need to go somewhere. And yeah, it also leads to increased time spent at home. Don't know whether it's a good thing or not, but maybe it will encourage you to do something with your apartment, right, at least. Yeah, so we talked about how the services shape the city, how the services transform it a bit. I mean, you know, it actually doesn't happen overnight, so you don't really see it until you think about it. And that's the point of current state of, you know, these future cities. We don't really have these future cities in the moment, because there's not much happening. It's just starting. And even if you, I don't know, even if you take all these points and you drive them to insanity, like you I don't know, you just imagine like the best possible case of development of the services, you won't actually see much on the streets. I mean, nothing will really change. Yeah, now we'll talk about machine learning in the services. Alright, I will discard you, but yeah, just listen about some machine learning stuff, because that's a lecture about machine learning, so we should at least discuss it. Alright, there will be a bit of interactive stuff, so now I encourage you to step up and make some propositions when I ask you. Try to answer my questions. Alright, for example, we have navigation system app, and you're a user of this navigation system app, but also you're a developer of this navigation system. I don't know, maybe you're a CEO of this company, and you're planning a route at the moment, like right now. But there is a small problem, because your route will take 30 minutes, and in 20 minutes, the road that you're going to pass, maybe it will become congested, like overwhelmingly congested. So you want to some kind of prevent this situation. You want to build a route that will take into account this some kind of future congestion, right? You want to avoid it. So what do we do? How do we try to mitigate this issue? Anyone? All right. If I say that maybe you can predict something, maybe you can forecast something.
Yeah, we need data.
Yeah, you need data. That you have lots of data. Yeah, so when you have data, you have interested parties, you have authorities, you have everything. But just what do you do? I mean, you, for example, you're this CEO of this navigation system company. Yeah, navigation system company. So how do you try to solve it? Because right now at the moment, the users are dropping from your app because they discover that when they're building their routes, the app is showing like 20 minutes. But then they realize that it's going to take 1 hour. It actually took 1 hour. So how do you solve it? Okay, the first one is on me, but all the next ones, I hope you'll do better. Yeah, you try to forecast the congestion. I mean, that was simple. That is really simple stuff, guys. It's not really about machine learning, it's about the product, it's about like some kind of envisioning the future. So yeah, you just gather some data about congestion, like every minute in all the roads in the city, and then you try to predict it based on historical data. That's all you do. That's how machine learning can actually help to improve this navigation system app. And while improving this navigation system app, you actually make people use it. And when you make people use it, you get all those benefits that I just discussed, right? Okay, the next one. You have a taxi aggregator. And you're ordering a taxi from an unknown place. For example, some friends invited you to some party and you've never been in this club and you just want to go home because it's over or maybe you didn't like it. So anyway, you order a taxi. But there's a problem. You need to choose a convenient pickup point. And you've never been here. You don't know where's the fences, where are the buildings, where is everything. You look at the map and it doesn't really tell you anything. But you need to choose wisely. Because if you choose the wrong one, you will wait for a cab maybe for 15 minutes or maybe 10, or maybe you won't even get it because the driver couldn't get to this club. I don't know, there are cases. So you need to choose a convenient one, but you don't know how. So now imagine that you're working on it in this taxi aggregator company. So how do you do it? How do you solve this problem for your users?
You highlight all the spots.
Yeah, you highlight all the spots. Actually, you can do it without machine learning. You can just take, all the historical points where driver and user met, and just go with the most, with the most frequent one. But actually, you can do better. You can predict the best one, and the best one is not always the most frequent one. For example, imagine. There is some change on the road at the moment, and I don't know, maybe 30 minutes ago it was a good pickup point, but right now it became much worse, and actually the second best became the best now. So machine learning can actually help it. It can predict the most convenient one. So yeah, that's how you improve. That one was good. Much better than the previous one. Thanks. Then, transportation system. Okay, I already told you how it's done, but just imagine, for example, you're late on a date and you're waiting for a bus and you don't really know whether it will arrive on time or not. Because, the schedule is saying like, yeah, you should probably wait for 5 minutes, but you don't have any options. Like, you either have this 5 minutes waiting and not a second more, or you just drop the bus and use a cab or use a car sharing. I don't know, anything except for the bus. So the problem is you don't know whether it will arrive on time or not. That's the problem for a user. The problem for guys who develop these apps is that they need to really correct this schedule. They need to tell you the real time the bus will arrive. So they can't mistake for more than 30 seconds, I guess, or a minute. So how do you solve it? How do you correct this expected time of arrival?
Analyze bus position and traffic situation.
Yeah, you just use these satellites, this GPS or GLONASS or anything. You just predict the correct time. But you can also do this without machine learning. You can just see what's the current situation on the road, like ahead of the bus, and you see that it's kind of congested, and the average speed there is 45 kilometers per hour, and then you just conclude that okay, the bus will arrive in 2 minutes. But still, you might be very much mistaken. Why? Because you don't know the driver. Like, the driver can make a lot of mistakes, actually. I mean, that's not really the point with the bus drivers, it's really the point with the taxi drivers. They can miss their turn. Again, not the point with this one. But they can, I don't know, maybe this driver is a very kind person and he's really polite, so he kind of passes everyone ahead of him. And just politely waiting for everyone to go, sacrificing himself and you who are waiting on the date, who are late on the date. So you can predict it. And actually for different drivers, you can like increase or decrease this average time that this ride is going to take. Yeah, so that's how machine learning can actually help. Like it can mitigate some very missing predictions based on just historical data without machine learning. Okay, I think that's the last one. Yeah, we have these food delivery services, and you're ordering food at rush hour. Yeah, the problem is obvious. You don't really know whether you will be able to order it or not. And just like now it appears like it's not a problem, right? You're sitting and you're thinking, well, okay, I can do it today, well, maybe tomorrow, or maybe the day after tomorrow. But when the day after tomorrow actually comes and you realize that you cannot do it still, you just start to think that maybe you should drop this idea altogether, right? Maybe you should plan like some alternative way to eat in the evening. So yeah, and you just drop this app, you just delete it, I don't know, stop to use it, and then if you stop to use it, then the app is actually dropping. The company will go bankrupt, and the city doesn't get all these benefits from these food services. So how do we solve this issue? That there may be no couriers.
Predict the delivery time.
Maybe.
It's not actually about predicting delivery time, because if there is no one who is going to deliver, what's the delivery time?
Who's predict the schedule of work of couriers?
Actually, you're doing it. I mean, again, you're solving this problem from the side of the business, right? You can actually do something with couriers, right? You can
move from.
Yeah, you can kind of you can predict the demand for this service at any given point in time. I don't know, maybe for tomorrow evening, and then you can optimize the number of people who are actually delivering food. Yeah, that's what you can do, and that's how machine learning can help. So far we're talking about this machine learning, and it doesn't appear very much impressive, right? I mean, it actually helps, but everything I just mentioned, you can do without machine learning and get maybe 70% of this benefit I was talking about. So yeah, machine learning in industry, like in terms of cities, it helps a bit. I mean, when you already have this, it's just like this Pareto principle, yeah? Like 20% of effort makes 80% of benefit. So actually, without machine learning, you can get 80% of benefit with 20% of effort. But if you want 100, then you can go for machine learning. And that's the current state of business, unfortunately. But now, a bit more encouraging things that will happen in maybe 5 to 10 years. And they're really exciting. They're going to change city landscape like a lot, really a lot. And it will happen overnight. First of all, the self-driving cars. I don't know, how many of you were thinking about this one? Okay, that's good. Not much, but still. So, how do they change the city landscape? First of all, if you have the self-driving cars, it means that this self-driving car can drop you near your workplace, and then it can go to some remote parking lot outside of the city area, right? And if it goes there, then you no longer need a parking lot near your workplace. So you don't really need parking lots in the city, like any parking lot. That's how they can change the city. I mean, there will be more parks, more buildings, more free areas, and all this stuff. But it's actually the second thing about self-driving cars. The first thing is the safety. Now, like, a lot of people are dying in car accidents, but with self-driving cars, which are actually better at driving than people, they drive more safely, and yeah, they can kind of dramatically decrease the amount of car accidents that's happening in the city. And I don't know how much it will shape the city landscape, but at least it will save a lot of lives, right? Okay, the next one is face recognition. That's actually a scary one. I mean, that's the talk about the trade-off between privacy and safety. I'm talking about safety because if you track any person on the street and you know who is this person, you can spot the criminal. I don't know, maybe he escaped from the jail, right? Or I don't know, maybe he's just some kind of weird guy that probably needs to be checked at least. So that's kind of a safety thing, and that will actually pretty much transform the city, because now in Moscow still there are some districts where it is quite alarming to just walk free at night. I mean, no, I won't say. Okay. I was going to name some, but the one I'm setting. Yeah. So with this technology, the number of these districts might decrease. I mean, of course, there will be some districts that will not change at all, because they're so into this stuff that nothing is going to change it, right? So, but still, many of these dangerous districts are going to end being dangerous, and that's the safety point. But the privacy point is that you will be monitored every second of your life, basically, when you're on the street, and that raises some concerns about, if you live in some kind of authoritarian country, and you're doing something that is not really in line with the dominating party in this country, some kind of surveillance can actually harm you in a way. Or maybe you're doing something that might appear suspicious, but you're not actually breaking any laws. But with this system, I don't know, you will be checked much more frequently, and that's upsetting. But this point on the line between safety and privacy, everyone chooses it for himself. Yeah, the next one is biometrics. For me, it is actually quite absurd that at the moment I have to take passport with me. I mean, passport, that's kind of a piece of paper. That's not even a card. But in Europe, everyone is using cards. And, these cards are even not biometric. And people need to just take this card and look at it and then, say something. Yeah, alright. You seem, it seems like you on this driver license, for example. But with biometrics, if you have some kind of a chip inside your arm, or maybe, that's far in the future, but maybe, like in 5 years, you will be checked by your eyes or your fingers. For example, if you're going to some kind of mall and you're trying to buy some booze, the guy in the shop is asking you how old are you, and now you have to carry a passport. But in 5 years, you will probably just need to carry your hand, and that will be it. And it's all these technologies, they actually exist right now, and they're precise, very much near to 100%. But still, authorities is the the stopping power for the technology in a way. So yeah, we don't have them now, but it will very much transform the city, because just imagine no one is going to carry some passport with them. I mean, that's a huge point. Yeah, and also the last point, I think probably the second one after, like the second biggest one after self-driving cars is data-driven city planning. In Moscow, there actually is some kind of data-driven city planning. I was reading about this strategy of placing some kind of shops on the street by Sobyanin team, and they were actually using data on kind of pedestrian flows. So it was data-driven in a way. But the Moscow is not end to it. There are lots of cities outside of Moscow. So, and they're not really data driven as us. So yeah, they can utilize a lot of data that even their cities create. So for example, you can start placing bus stops at right places. I mean, how many times you've seen a bus stop that is never utilized? Like never, literally never, in the middle of nowhere. Nothing is placed there, but the bus stop is there. I mean, maybe you want to walk free and never get back from there. Now like you can place them in the right place, and that's the point of this like pedestrian flows. I don't know, or maybe data on some kind of organizations near the presumed spot of the bus station. Okay, the next one is smart housing development. That's a big one actually, because how many of you are spending more than 20 minutes to commute to your work or the university? Like more than 20 minutes. That's actually quite a lot. I mean, why don't we develop some kind of housing that will comply with the organizational structure of the city? Like, just imagine, a lot of people are actually commuting from the suburbs to the city center every day. Like, a lot more than it must be. So we can start developing some kind of distributed system of organizations and housing that will, for example, I work at Yandex, right? So I might want to live around Yandex, so I can commute like 10 minutes by walking, right? So Yandex and authorities can actually cooperate on this, and when they're building their office, they can also, like talk to some developers and develop some housing for Yandex employees, because we have like 20,000 people or like 15, so there are, I don't know, 3 houses, like 3 very, very, very big houses nearby. So that is the next big thing actually in city planning, I guess. Yeah, the last one is quite funny, the prevention of ghetto emergence. In some cities there are some kind of ghettos, and that's not a good thing. We can prevent it by analyzing social media with machine learning. So machine can read all the tweets, it can watch all the videos, all the photos, and everything. And by analyzing such huge amounts of data, it can predict the emergence of some ghetto in some district. For example, a lot of people with some kind of criminal attitude to life, they're all supposedly are going to live in some kind of district that will, like, make no mistake, that will make a district criminal. Maybe. So we can prevent it, right? I don't know how, because that's the question to authorities. I'm not gonna elaborate it, but we can at least try. And like, guys, you can imagine thousands of ways to improve the city with some kind of data. Yeah, the takeaways, the main part. That, this presentation, it doesn't contain any numbers or some kind of really serious and deep analysis of everything I'm talking about, but I was actually hoping to encourage you to at least invest some time in researching some kind of machine learning in this urban planning. And the takeaways, the bullet points from the whole talk. First of all, cities has a lot of data, literally a lot, unlimited amounts of data, and that is exactly what machine learning needs. So city and machine learning, they're kind of bonded, and you can just dive right in and use your data with machine learning, and everything's going to be great. The second one, some services are significantly transforming the city. For example, taxi aggregators and car sharing services, and navigation systems. And this transformation is in a way significant. Of course, it's not as significant as self-driving cars, but still, you can notice it when you think about it. But machine learning now plays very, very minor role in all this transformation. That's really unfortunate for me because, I'm a machine learning engineer and data scientist, and I'm upset when I hear that. But that's the sad truth. But the big transformation is yet to come. I've told you about self-driving cars. This year, Yandex has 100 of self-driving cars on Moscow streets, and they will be tested. And if it's going to be alright in 2 years, then maybe in 5 years, maybe 30% of cars in Moscow, at least the taxi cars, they might change to self-driving. So, that will, make no mistake, it will transform the city very much, like a lot more than anything that we have now. And self-driving car is kind of 90% machine learning product. So, this role of machine learning in self-driving car, in face recognition, and then smart city planning, it will be very, very big, like a very major role. So, our time is coming. Maybe in 5 years, maybe 10, but maybe less. Depends on how motivated you are. And the last one is a tricky one. That's the only thing that stops all these technologies from emerging. It's the morals. I'm talking about the case, for example, you have a cat and a dog on the right lane and a person on the left lane. And you have a self-driving car that cannot stop for some reason. So who should it kill, right? No one knows. And also, who will be responsible for some kind of car accidents? Will it be a person who is in the back seat? Will it be a company who developed this self-driving car? No one knows. And that is the only thing that's stopping the self-driving cars from actually driving on the streets, because the technology is ready. It's already better than the human, so why not use it? The morals is the obstacle. The next one is ethics. It also connected to self-driving cars mostly, but also to face recognition, because is it ethical to watch people on the street? I don't know, do you stare at people on the street when you walk there? Not much, right? So, but what does change if some kind of the guy who's behind the camera is watching at you, staring at you, but on the video? What's changing? Nothing. It's still unethical, right? So we have to work it out. And the last one is privacy. That's a big concern with face recognition. With self-driving cars, I don't know, probably there is some kind of privacy issue, but not much. In face recognition, it's the giant one, and maybe in some other use cases with data-driven city development, it's also the case. Thank you. Now I think I will take some questions. Well, okay, let's go over it. No one?
So, how do you think, there is a problem like traffic jams, especially for Moscow, it's actually a significant problem. How do you think for the last 3 or 4 years, with the existence of Yandex.Taxi and Uber, and again another digital taxi aggregators, how do you think how the situation of the traffic jams has changed?
I think the situation with traffic jams didn't really change because you know, there is this kind of paradox called Pigou-Johnson or someone paradox that says if you build a new road, you will have decreased traffic jams for only a little while, and in some prolonged time, in the long run, you will have the same amount of traffic jams. Why? Because before, like when like in this default scenario where there was a traffic jam, some people refused to drive a car. But now, when we have a new road, maybe some people will drive, and when people will drive, it will stabilize to equilibrium, and there will also be traffic jam. So, for Moscow has this problem because we have a lot of people. For example, in some kind of a small city with a lot of space, there won't be a problem, right? But I guess in a large city like Moscow, there is no escape from traffic jams, ever.
Such kind of new digital taxi navigators seems to be more effective or more efficient than traditional ones.
Yeah, that's true. But you know, when you sit in a car with your friends, for example, 4 of you, you have 3 cars less on the road, right? But it also means that 3 people from public transport are driving now, because you vacate the place for them. So actually, the number of cars on the road is the same. Yeah, that's kind of the paradox.
I also have a question or comment regarding the traffic congestion and the taxi services. You actually mentioned that it is reducing the congestion, but there's now a whole lot of research that's saying that actually Uber and Lyft and other services are increasing congestion. So how do you plan to reduce this? When drivers are going to the new pickup place, so it introduces a share of the increase of the congestion and the traffic jams in the city. So how do you react in terms of this decision?
You know, the thing is, most of the companies, like the private companies from the private sector, they don't really think about the good for the city. They think about optimizing their profits mainly. So I don't know about Uber. In Yandex we're actually trying to save everyone, to save the city, to save ourselves. So I guess someone in our company is thinking about how to decrease the congestion, right? And the first obvious step is to popularize pool rides. I'm not pretty sure that pool rides will mitigate the issue, because as you've told, and I've also seen this report about Uber and Lyft, kind of taking the rides from the bikes and the scooters and just placing people in cars. Nevertheless, there are pool rides. This is the problem. But I guess that some kind of pricing policy for scooters, for bikes, and for taxis combined together, optimized for not for profits of taxi service, but for the benefit of the city, can change it. If you make a good bike, not like ours on the streets, if you make a good rental bike, I don't know, maybe for $1 a day, then everyone will use bikes. I mean, not everyone, but a lot of people, because bike is convenient, bike is good, and it's now cheap. But what we have now, we either have a bad one, or we have or you have your own, and your own is actually inconvenient because you have to leave it somewhere, you have to risk it because maybe someone is going to steal it. So yeah, I guess if taxi services start to enlarge and take markets of bike sharing, of scooter sharing, and all this, then with combined efforts, maybe it is possible to reduce congestion. But now, not really.
Is Yandex helping to solve is Yandex helping the government to solve different issues?
You know, there wasn't an official press release on this, so I kind of not allowed to tell about the negotiations with government. I'm sorry, but I guess, in a way.
Yeah, I wanted to ask about, I mean, you partly answered the question that Yandex.Taxi is kind of thinking about the profit, and you can't be biased when you're telling that, like, all the aggregated taxi is very, very good, but I wanted to ask if you're thinking about social implications of this employment. Like you're saying, like, yeah, it's a lot of employment and migration, but it's controversial, right? So this employment is informal, and there is a certain devaluation of like the taxi driver work, and they can be also kind of irresponsible having that people money for the ride. And how do you comment these issues? Do you think about that in Poland? Are you trying to solve the social implications of this?
Yeah, for sure. For example, there's a lot of pressure from authorities because of, you know, kind of illegal driving, because a lot of drivers can kind of register with a fake driver license, and it is very hard to check it unless you have this person online, like not like offline, sitting in front of you. But you cannot possibly imagine looking at driver licenses of new drivers with them present at your office, and you know, like we have lots of new drivers every month, like very, very, very lot. So the problem is you can't do it, so you rely on some kind of technological solutions to do this, and the authorities are pressing, and when they're pressing, there is a large, like big motivation to solve some kind of social issues connected to the bad driving, or drunk driving, or I don't know, or actually the main issue is tired driving. A lot of drivers are working for 16 hours a day, and they become really tired, and then there are lots of car accidents and all this stuff. Yeah, that's bad. But you know, the bottom line is 5 years or 10 years, there will be no drivers, because everything is gonna be overtaken by self-driving cars. So yeah, we just have to wait. But now we're working like really much working. There are lots of people in Yandex.Taxi who are really working on you know, making the rides more safe. Yeah.
Could you please explain the basic difference between artificial intelligence, neural networks, and machine learning, deep learning? What's the difference?
All right. That's actually a large question, but I can briefly explain the difference. For example, if you have some kind of a Telegram bot, right? And you just made a rule that if anyone is texting you thank you, then you reply with you're welcome. Yeah? That is artificial intelligence. I mean, yeah, because some machine is analyzing the text and popping out this you're welcome phrase, right? But there is no data involved, right? There is no machine learning, there is nothing at all, as you call it, intelligent. Paradoxically, because that's artificial intelligence. Because you know, like every rule that enables machine to act like it's intelligent is artificial intelligence. So it's just about making machines appear intelligent. Machine learning is actually about utilizing lots of data and trying to deduce some kind of relationship from like relationship of your, I don't know, maybe images to some kind of labels, or text to labels, or I don't know, something to something. So utilizing like large amounts of data, you try to deduce some kind of relationship in this data. That's machine learning. So the data is crucial here. For artificial intelligence, there is no requirement of data. You can do it without data. And deep learning is a subset of machine learning when we use neural nets, and that's it. Like, neural net is just another type of algorithm. For example, you have an algorithm called linear regression. Maybe some of you are familiar with it, and that's just, you know, the simplest type of neural net. So neural nets are not magic. It's just, you know, kind of multiplying and adding some numbers, and that's it. So it's a kind of a function, non-linear function. Yeah. That's the difference.
Just like quick question on traffic and data collection. We
Yeah, okay. That's actually pretty simple. Once you realize it, all right, how many users do we have on the road right now? And how many of them are using our navigation system? Probably a lot, right? I mean, if someone is passing nearby and is using our navigation system, we can track his position maybe every 5 seconds, right? And we can track how many meters he passed. So with that in mind, we can calculate the speed. And when you calculate the speed, you kind of color all these nodes and all these edges on the map. So if the speed is close to 60 kilometers per hour, you have a green one. If it's 10 or 5, it's red one. So yeah, that's the data collection in navigation systems.
Do you have a problem with some emergency or bikers who like just lost?
Yeah, that's a problem. That's a problem when you have very little user base, right? If you have like 5 people in the city, your data is unreliable. If you have maybe 50% of people using your app in the city, your data is more than reliable because 10 people will pass with a speed of 60 kilometers per hour, and maybe one pedestrian who is trying to, like get funny, he tries to mock you, to lie to you. He just kind of builds this route and just walks. So it may appear to your navigation system that the speed there is 5 kilometers per hour, but it's actually not. And if you have only this pedestrian, then yeah, you're mistaken. But if you have 10 more, you can easily deduce that this one is trying to get funny. And the 10 good guys are actually providing you with the reliable data. Alright, I think one last question, and that's it. Alright, who doesn't know Russian? Можно по-русски.
Есть какие-то исследования по оптимальной структуре рынка, каршеринга, с каким-то социальным преимуществом, в зависимости от структуры рынка? Сколько будет игроков, в зависимости от этого больше будет пробки, сколько конкурентов должно быть там в Яндексе, грубо говоря, оптимально?
Да. Ну, я скажу так. Можно по-русски, да? Я скажу так, конкуренты должны быть всегда у всех, потому что только конкуренты делают так, что ты можешь развиваться. И развиваться быстро, как бы под давлением. Но вот исследование о том, сколько оптимально, как было бы хорошо и так далее в отношении города, это зачастую нереально. Потому что симуляции города, какие бы они ни были, это ультрасложные истории, они не бывают большими, они не бывают масштабируемыми, они не бывают близкими к реальности. Потому что как только это становится близким к реальности, это можно симулировать только для деревни, где живет 20 человек. Вот. Что касается вот таких прям исследований рынка, где есть несколько игроков, где есть человеческий фактор в принятии решений компаний, где есть множество других факторов, где можно учесть еще кучу всего, там вообще невозможно провести такое исследование, чтобы оно было каким-то более-менее адекватным. Конечно, можно подойти с точки зрения теории игр, обрисовать какую-то более-менее простую модель и попытаться решить эту модель, вернее, эту игру, и понять, что вот оптимально в случае максимизации как бы social welfare было бы иметь вот столько конкурентов. Но, честно, это будет настолько же далеко от истины, как если я сейчас просто скажу 5.
Хотя бы один, для Яндекса хотя бы один.
Я одного очень быстро убью.
Нет.
Right, thanks everyone.
Хотя бы один.
See you later.